guys, and welcome back to the session. So once again we are here, and this time we will be doing some super good 10 questions from the chapter Electrochemistry, and this time I have taken the questions which are from the JEE mains pattern. Okay, so I have tried to cover all the 10 as different questions so that we can quickly revise the complete chapter. So without any further ado, let's directly move on to our first question. Let me read the first question for you. So the first question that you can see here, it says that the standard reduction potentials for Zn2 plus to zinc. So some couples are given, nickel 2 plus is getting converted to nickel and iron 2 plus is getting converted to iron, and the standard reduction potentials are given to us. Okay. So respectively. Now we need to say the reaction X plus Y2 positive to form X2 positive plus Y will be spontaneous when. So we just need to say when X is this or this, and correspondingly Y are these values, so then the reaction has to be spontaneous. So we need to find the perfect couple for X and Y so that the entire reaction is spontaneous, right? So how you should be doing? So see, rather than talking in the terms of oxidation potential, reduction potentials, because all the reduction potentials are given the negative values, let's directly consider the oxidation potentials. Okay, so see what I'll do. So first one says that when you are going from Zn plus 2 to Zn, then second says that nickel plus 2 to nickel, and the third it says that iron plus 2 to iron. Right, so these are the three couples which are given, and their reduction potentials are given to be minus 0.76, then we have minus 0.23, and the third one we have is minus 0.44 volt, right? So I am not concerned about reduction potentials. Let me write their oxidation potentials. That means if I write the opposite way, zinc getting converted to Zn2 plus, nickel getting converted to Ni2 plus, and then we have iron getting converted to Fe2 plus, right? So I just reversed all of them, and their values will come out to be 0.76 volt, next is 0.23 volt, and the next is 0.44 volt. Okay. So which one has the tendency to undergo oxidation? So see, if I write the tendency to undergo oxidation. So which one has more tendency to undergo oxidation? The one which has higher positive oxidation potential. So 0.76 is the highest. So zinc would love to undergo oxidation. Then out of these two, iron would love to undergo oxidation, and then the left out, nickel will love to undergo oxidation. Okay. Now see, let me remove everything. So this is not needed. Let us now write the option. So it says that if you take the reaction X is combining with Y2 positive to form Y plus X2 positive, right? Now let's choose. First X is iron and Y is zinc. So first X is iron and Y is zinc. So I told you, right, the tendency to undergo oxidation was greatest for zinc, and here it is saying zinc wants to undergo reduction whereas iron wants to undergo oxidation. No. This is not the correct option because this is opposite to what I have taught you. So this is wrong. Now let us compare the second part. Second part says that, so let me do the comparison one by one. So if I am doing the second part, X is zinc and Y is nickel. So see, if I compare zinc and nickel, come and see here. So now see, compared to nickel, zinc is having lots of tendency to undergo oxidation, right? And here I am saying zinc wants to convert to Zn2 plus and nickel wants to undergo reduction. Yes. So the reaction will happily take place, and this reaction will be spontaneous also. Okay. So with this thing, I can simply mark option number B as the correct option for this question. Now no need to compare this and this because we have already rechecked it and this is the correct answer. Okay. So this was our first question, a good question, right? Fine. So having done the first question, I think now we should be moving on to our second question. But before I show you the second question, let me just clean the board. And now on the board, you will be able to see the second question. And let's see what it says. So the question says, the correct order of equivalent conductance, so that means you need to talk about lambda EQ at infinite dilution. So you don't have to talk about lambda EQ, rather you have to talk about lambda EQ infinity of LiCl. So you are given LiCl, right? So how will you write lambda EQ of LiCl? You will say this is lambda EQ infinity of Li plus lambda EQ infinity of Cl minus, right? Now we have NaCl, so let me just write for all. Lambda EQ infinity for NaCl will be equal to lambda EQ infinity of Na plus lambda EQ infinity of Cl minus. And the last one is KCl, so lambda EQ infinity of KCl is equal to lambda EQ infinity of K plus lambda EQ infinity of Cl minus. Am I right? So you need to compare the lambda EQ infinity value for all the three salts. See, this part, this part, this part is same for all of them. So the deciding factor is this part, right? So we need to decide on the basis of Li plus, Na plus and K plus, right? Now see, please do not say, ma'am, lithium is the smallest in size, then sodium and then potassium. So the one which is smallest in size will quickly move. So lithium should be moving very, very fast. And lambda EQ infinity of lithium should be maximum. No. Look at the question once again. The question says you need to talk about the infinite dilution. So infinite dilution means that the solution you have taken is aqueous. And when I say that the solution is aqueous, I mean to say the hydration of ions will be taking place. Now since lithium is the smallest in size, it will capture lots of water molecules. So many water molecules will come and they'll make lithium a very big ion. So Li positive must be the smallest ion, but Li plus aqueous will be the biggest ion compared to Na plus aqueous and K plus aqueous, right? Because the hydration of Li plus will be largest. And when I say that Li plus will be hydrated to a large extent, so it will become bulkier like an elephant and it will be moving very, very slowly. And when I say that it moves very, very slowly, I mean to say the lambda EQ infinity of LiCl will be least. So here it is saying maximum, not our option. Here it is saying least, then NaCl, then KCl, correct. Here it is saying least, but out of Na and K, the trend is usual. K will be biggest, so hydration will be less and hence movement will be more. So even this is not the correct answer. Here it says LiCl is maximum, no. So simply stating the fact that option number B is our correct option for question number 2. Okay. Once again, it was a good question up to the mains level. So now let us move on to the next question, and here we come with our question number 3. Give me a minute so that I can clean the board. Fine. So now if I move on to our third question, our question says that the electrolysis of dilute aqueous NaCl solution was carried out. So let me read it again. Electrolysis of dilute aqueous NaCl solution. So see, when it is dilute solution plus I am saying it is aqueous solution. So what are the ions which will be present? We will have Na plus aqueous, we will have H plus aqueous, we will have Cl minus aqueous and we will have OH minus aqueous. So these are the 4 ions that will be present, right? So electrolysis of dilute aqueous solution of NaCl was carried out by passing 10 milliamperes of current. Let me write the value of current. 10 into 10 raised to the power minus 3 ampere of current was passed, right? The time required to liberate 0.01 moles of hydrogen gas. 0.01 moles of hydrogen gas is to be liberated at the cathode is. So you just need to tell me what is the time which will be required to evolve 0.01 mole of hydrogen gas. Okay. So I am not concerned about NaClOH. I am only and only concerned about H plus. Fine. How will I write? See here carefully. I will say that H plus aqueous plus electron to form hydrogen in the gaseous state, right? So now I have 2H plus 2 electron to form H2 in the gaseous state. Okay. So from here can you say that 2 into 96500 coulombs of electricity of electrons. So see, 2 Faraday or 2 into 96500 coulombs of electricity will be required for the production of 1 mole of hydrogen. So if 1 mole of hydrogen gas is to be produced, you need 2 into 96500 coulombs of charge, right? We don't need 1 mole, rather we need 0.01 moles. So what I'll say, 0.01 moles of hydrogen gas will be produced by the passage of how much charge? You need to have 2 into 96500 into 0.01 coulomb. So this is the total amount of charge that is required for the production of 0.01 moles of hydrogen. Okay. Now since I know the total amount of charge, I know the current, I can easily use the formula. This formula you know, right? So we say that current is equal to the charge transported divided by the time taken, right? So you know the current. How much current is given? 10 into 10 raised to the power minus 3 amperes. Amperes is coulombs per second. Now how much charge is required? So we have 2 into 96500 into 0.01 coulombs divided by time, right? Now see, this coulombs and coulombs get cancelled. So time will come out to be 2 into 96500 into 0.01 to be divided by 10 into 10 raised to the power minus 3 second inverse. So if second inverse is there in the denominator, it will go in the numerator and it will become seconds. Fine. If you solve this, I just solved this before I solved here. So I was getting 19.3 into 10 raised to the power 4 seconds as the correct answer. Fine. This is simple calculation. You can do the calculation by yourself and let me know if the answer that I have marked here is correct or not. Okay. So guys, this was our third question. Now I think we can move on to our next question, which is question number 4. So let me once again clean the board. So guys, please do expect one question in paper from this electrolysis. So generally from the chapter electrochemistry, either you get the question from electrolysis or you get the question from those half cells. So this is also one good topic to get the question from. Fine. Finally, moving on to our next question, which is question number 4. Now the question says zinc to form Zn2+. Okay, so there is a cell which is written. Let me just write it. So I say that zinc is getting converted into Zn2+ with the concentration or activity given to be 0.1 molar. And then there is a salt bridge. Then you have Fe2+ activity is given to be 0.1 molar again. And then we have iron. This is the cell reaction given. The EMF of the above cell is, okay, we are also given the EMF of the cell, which is 0.2905. So 0.2905 0.2905 volts, and you need to tell me the equilibrium constant. Okay, so this is what you need to tell me. Fine. Can you first of all calculate what is the E naught of the cell? Let's try to do the calculation for E naught of the cell. So for that we need to use the Nernst equation, and to use the Nernst equation we first need to write the equation for the cell reaction, right? So see here, this is the anodic compartment and this is the cathodic compartment, right? So I will say zinc solid is losing 2 electrons to form Zn2 plus, which is 0.1 molar in concentration, and the another is Fe2 plus, which is once again 0.1 molar, will accept 2 electrons and form iron in the solid state, right? Now do the overall calculation. So 2 electrons get cancelled. You will have zinc solid plus Fe2 plus 0.1 is gonna form Fe solid plus zinc 2 plus, which is 0.1 molar, right? Now if I ask you to write the Nernst equation, so I'll say E cell is equal to E naught cell minus 0.059 by N log concentration of products to be divided by the concentration of reactants. Okay. Now E cell is given to me as 0.2905. I don't know what is E naught of the cell. Let me just write it as E naught minus 0.059 divided by 2 log of, see what is there in the product, 0.1 molar zinc, and in the reactant 0.1 molar iron. So the concentration is 0.1 divided by 0.1. Now this becomes log 1, the whole term becomes 0, right? And when the whole term is 0, you can simply write E naught of the cell is 0.2905 volts. Okay, I have solved this completely, but in case if I do not want to solve, then also you must be very much clear that if the concentration of products and reactants are given to be same, stoichiometric coefficients are 1 and 1 respectively, then the E cell will be same as E naught of the cell. Okay, but since not everyone is very clear with this concept, so I have explained you. Fine. Okay, so first part of the question is done, that we got the E naught of the cell. Now let us do the second part of the question. The second part of my question was to calculate the K equilibrium. So when I say that the reaction is in equilibrium, I will say that the E cell will be 0, right? And the E naught cell will be 0.059 by N log of K equilibrium, right? So this is what is the final answer. So E naught cell is 0.2905 is equal to 0.059 by 2 log of K equilibrium. Am I right? Then take everything to the left hand side. 0.2905 into 2 to be divided by 0.059 is equal to log of K equilibrium. Okay, and if you do the calculation of K equilibrium, you will get 10 raised to the power minus of 0.2905 multiplied by 2 divided by 0.059. This will be the final answer. And if I ask you to solve it, I just solved it, so you will be getting something like this. Okay, you can solve it. This is very simple calculation, and you will be getting option number B as the final answer to this question. Okay, not at all a tough question, but yes, a tricky and an easy question as well, right? Okay, so this was all about our question number 4th. Now I will be proceeding on to the next question, and this will be the 5th question. Give me just a minute and you will be able to see the next question on board. So the next question that you can see on board is question number 5, and the question says the standard reduction potentials E naught for the half cell reactions are given. So there are two cell reactions given, and for these two half cells that are given, the standard reduction potential values are. So first is zinc is getting oxidized and the E naught is given to be 0.76 volt. Okay, and then we have iron getting oxidized, and now the E naught values are okay. Now you simply need to calculate the EMF of the cell that is given to me. So the EMF of the cell that is given to me is zinc plus Fe2 plus is gonna form Zn2 plus Fe. So this is the cell reaction whose EMF we need to calculate. Okay. So how should I be doing? So see, the standard reduction potentials are given and you just need to calculate the cell. See, in this particular question, nowhere you have been given the concentrations. You are not given, so you can just assume the concentration to be 1 molar each. And when I am saying assume concentrations to be 1 molar each, you just need to calculate the EMF or E naught of the cell. So how will I do the calculation? So E naught of the cell could be written as reduction potential of electrode. So E naught reduction. Reduction potential of electrode where reduction is taking place minus reduction potential of electrode where oxidation is taking place, right? So see, let us figure out where reduction and where oxidation is taking place. According to this cell, iron 2 plus is getting reduced, right? So I'll say E naught of the cell is E naught of reduction of Fe2 plus to Fe, okay, minus E naught of Zn2 plus to Zn. You need to substitute the values. Now see, first let us come to Fe. So Fe to Fe2 plus, the oxidation value is given to be 0.41. So the reduction potential will be minus of 0.41. So substitute it here. Minus. So for Zn to Zn2 plus, answer was 0.76. So the negative will be minus 0.76. Right? Now if I ask you to solve it, you will get 0.76 minus 0.41. And when you solve it further, you will get 0.35 volts. Okay? Let's check if the options are there. So minus 0.35 plus 0.35. Yes, we have. Right? So that's it. Option number B is the correct option for this particular question. Okay? So this was about your question number 5. Now note the solution and then we'll move on to the next question. Okay, so I think everyone is now done noting down 5th question also. Let us move on to the next question, which is question number 6. Okay, so on the screen you can see question number 6. Let me try doing it. If 3 Faradays of electricity is passed through the solutions of AgNO3, CuSO4, AuCl3, the molar ratios of the cations deposited at the cathode is. It's not a tough question, it's an easier one. So see what it says. It simply says that I am passing a total of 3 Faraday electricity. So a total of 3 Faraday of electricity is passed through an aqueous solution. What are the aqueous solution? You have aqueous AgNO3, then you have aqueous CuSO4, and third you are having aqueous AuCl3. So see, he is not asking you to tell how much charge has been passed because 3 Faraday of charge is passed thoroughly. He is asking you to tell the ratio of the cations that have been deposited. So let's do one thing, let's simply write down the equations. So first I'll write Ag plus aqueous will accept an electron to form Ag solid, right? Then or let me do one thing. Let me start writing from here so that we get a proper answer. So first is Ag plus aqueous will accept an electron and it will lead to the formation of Ag solid, right? Then second is Cu2 plus aqueous will accept 2 electrons and form Cu solid, right? And the third is Au3 plus aqueous will again accept 3 electrons to form Au solid, okay? And now what I'll say? Now I will simply say, so see here, can you say from this statement that 1 Faraday of electrons, when 1 Faraday of electrons will be passed, how much cation will be deposited? You will be getting 1 mole of the cation. So 1 mole of the cation will be deposited if 1 Faraday of charge will be passed. So 1 mole. And this is, I won't be writing it again and again, it's 1 mole of cation. Okay, but if I'm not passing 1 Faraday, I am actually passing 3 Faradays of electricity. So when I pass 3 Faradays of electricity, I will be getting 3 moles of cation. Okay, I am keeping it in box because this is important. Now moving further, can you say that when 2 Faraday of charge will be passed, how much cation will be deposited? 1 mole. So 1 mole cation will be deposited when 2 Faradays of charge will be passed. But when 1 Faraday will be passed, 1 by 2 mole will be deposited. And when 3 Faraday will be passed, you will get 3 by 2 moles of the cation will be deposited. Keep it in box. Okay. Moving here, when 3 Faraday of charge will be passed, only 1 mole of charge will be deposited. Now you keep this in box, right? So we basically need to tell the ratio of the cation which is deposited. So how will I move on? So now I'll be working with the boxes. So first is 3 moles, this is an important term, ratio, then this is not needed. Then another is 3 by 2 and then 1. So we have 3 ratio 3 by 2, ratio 1, right? But see, are the options given 1, 1, 1, 1. So no fractional option is there. So let's do one thing, let's multiply the whole thing with 2. So what you will be getting? You will be getting 6 ratio 3 ratio 2. Clear? Let's check out the option. 1, then we have this 6, 3, 2. So option number D is the correct option for this question. Good question, right? I mean, this was a nice question. And you know what? Although this thing is very, very simple, but I have seen students getting so confused now how to move on to the next ratio. So please do not forget that you are already in 12th and you have passed class 1 and 2. So do not forget the concepts which were taught to you when you were a small child, right? So this was our 6th question. Let's now move on to the 7th question. The 7th question now says the reduction potential of hydrogen half cell will be negative. Give me a second. Yeah, so this is the 7th question and it says the reduction potential of hydrogen half cell will be negative. So we need to talk about E of H plus to H2. So this is reduction. I want the value to be negative. When the value of reduction potential of hydrogen half cell could be negative. So here he has talked about pressure and here he has talked about the concentration. So the best possible thing is to first write the hydrogen half cell. How to write? I will simply say H plus aqueous plus electron to form half hydrogen in the gaseous state, right? Or in a better way I can write 2H plus aqueous plus 2 electron to form hydrogen in the gaseous state. right? Let's write the Nernst equation corresponding to this. So we say E H plus 2H2 will be equal to E naught H plus 2H2 minus 0.059 by N. When you work with this equation, make sure N is 2. If you are working with this equation, N will be 1, right? So minus 0.059 by 2 log of, let's write. So see, here we have hydrogen in the gaseous state. So I'll write log of pressure of hydrogen raised to the power 1 to be divided by concentration of H plus raised to the power 2, right? Now what all I don't need? See, we already know that E naught of H plus 2H2, the standard reduction potential of hydrogen half cell or hydrogen is 0. So 0 volts. So what will I be getting? I will simply be getting, I don't need this. So I can simply write E of H plus 2H2 will be minus 0.059 by 2, right, log of pressure of hydrogen divided by concentration of H plus raised to the power 2. Okay. If we want the E to be negative, see this already negative is there, this is positive. So I just need to make sure that pressure of hydrogen by concentration of H plus raised to the power 2 should be a value greater than 1, not 0. If this value will be greater than 1, then log of something greater than 1 will be positive. When log will be positive, this is positive and one negative is already there, then E will be negative, right? So first, so let's start putting the values which are given. So first it says, let's see all the options. It says pressure is 1 to be divided by H plus square, 2 square. So 1 by 4, 1 by 4 is less than 1. So this is not the correct option, right? Move on to the second option, pressure is 1 and H is 1, which is 1. I said that the pressure of hydrogen by H plus square has to be greater than 1, not even equal to 1. Because if it will be equal to 1, the E cell will be 0. So even this is not the option, right? Check the third option, pressure is 2 divided by concentration is 1. 1 square is 1. So see 2. And now we know 2 is greater than 1. So that's it. This is the correct answer. So I'll say option number C will be the correct option for question number 7th. Again, a good question. Okay. Now having done with question number 7th, let us move on to the next question. Now on the screen, I will display the next question, which is our question number 8. And the question number 8 says that you are given the values E naught of Cr3 positive to chromium. So the reduction potential of chromium is given and this is minus 0.74. Okay, moving further, E naught of MnO4 minus to Mn2 plus is given to be 1.51 volts. Next is E naught of Cr2O72 minus to form Cr3 plus is given to be 1.33 volts. And E naught of Cl to Cl minus is 1.36 volt. Okay. And he is saying based on the data given above, the strongest oxidizing agent. Let me now explain. So you need to find out the strongest oxidizing agent. What is oxidizing agent? Oxidizing agent means the one which will be responsible for oxidizing others. So it wants to oxidize others. And who would like to oxidize others? or the, let's say, the compound which will want to undergo reduction. So itself undergo reduction. So any particular species or any particular compound which will have the highest reduction potential. So if any species will be having the highest reduction potential, will be the one which would love to undergo reduction quickly, will be the one which will help in the oxidation of others, will be the one which will be the best oxidizing agents. Let's compare the reduction potentials. So see, this is plus 3 to 0. So every potential is reduction, but the maximum I can see is 1.51 volts, which is MnO4 minus. So the answer will be D option, MnO4 minus. Okay, this was a straightaway easy question, so do not mess up with the negative and the positive signs. Make sure you are reading the question properly. Make sure you check whether this is oxidation or reduction potential which is given. Fine. So that is the only thing that you have to be concerned about in this question. Okay. Now having done with this question, let us directly move on to our next question, which is question number 9. Let me clear the board and see what the 9th question is. So question number 9 is saying, okay, once again a cell representation is given. So you have a platinum wire, then you have hydrogen gas which is given at a pressure of 0.4 atm. Then you have H plus aqueous which is given to have a pH 1. So you know, right, what is pH? pH is minus log of H plus, right? So if pH is equal to 1, the concentration of H plus is 10 raised to the power minus 1. I am just writing the concentrations, I am not writing the pH. Then we have a salt bridge. We have H plus with a pH 2, so the concentration will be 10 raised to the power minus 2 molar. Then once again we have hydrogen in the gaseous state, but this time the pressure is 0.1 atm. And then we have a platinum wire. Okay. And you need to simply tell me that the measured potential at 25 degrees C is. Temperature is given to me as 298 Kelvin. So tell the E cell. Now to tell the E cell, our first requirement is to write the cell reaction, and that too with proper concentration terms. How to move on? See. So this is oxidation and the another one is reduction. So I will say H2 0.4 atm will lose 2 electrons to form 2 H plus, which is 0.1 molar. Please make sure that you write this pressure and this concentration, otherwise since the species are same, you will end up getting confused later on. And here since you can see it is undergoing reduction, so from plus 1 it is going to 0, so you will say 2H plus 10 raised to the power minus 2 will accept 2 electrons to form hydrogen with 0.1 atm, right? And then I'll say you need to add the 2. When you add the 2 equations, you will get hydrogen 0.4 atm. See, 2 electrons and 2 electrons will get cancelled, plus 2H plus, which is 10 raised to the power minus 2 molar, okay, will be giving us 2H plus, which is 0.1 molar, plus which is giving me hydrogen, which is 0.1 atm. Okay, so this is my final cell reaction that is given to me. Now I need to use the Nernst equation. Let me see, where is the duster? Yeah. So since we have to use the Nernst equation, I will simply write E cell is equal to E naught cell minus 0.059 by N log concentration products by concentration reactants with each concentration term raised to the power stoichiometric coefficient. E naught cell is 0. You are very smart, right? And then you can say E cell is minus 0.059 by. See, here I have used 2, here I have used 2. Now don't say number of electrons is 4. You know, right, same number of electrons get transferred throughout the reaction, divided by 2. Log of products by reactants raised to the power stoichiometric coefficient. Let's put the values. I am erasing the above part because we don't need it anymore. So let me start putting. The E cell comes out to be minus 0.059 by 2 log of. So let's start with the products. So this is 0.1 raised to the power 2. Once again 0.1 to be divided by reactants. So 0.01 raised to the power 2, which is to be divided by 0.4. The calculation is not at all tough. Once you solve everything, you will end up getting minus 0.041 volt. So this is how you will be able to calculate the EMF of the cell. Fine. Again, this was an easy and a really good question. Fine. So having done this also, we are now left with our last question, and let us now move on to that question as well. So this last question says, the equivalent conductance of 0.1 molar weak acid HA. So let's say there is a weak acid HA which is given to me, whose concentration is 0.1 molar, okay, and its equivalent conductance lambda EQ is given to be 10 Siemens centimeter square equivalent inverse, and that of its infinite dilution is given to me as 200 Siemens centimeter square equivalent inverse, and I am asking you to calculate the pH of the solution. See, the question is very good, and this question is up to the advanced level also. See how we will be proceeding on to the answer. When I know the value of lambda EQ, and when you know the value of lambda EQ infinity, you can simply, and it's a weak acid. So you know alpha could be written as lambda EQ divided by lambda EQ infinity, right? So this will be 10 divided by 200. So this will be 1 by 20. So you know the value of alpha. Now once you know the value of alpha, and since you know it's a weak acid, you can write HA aqueous will be forming H plus aqueous plus A minus aqueous, right? Let's say the concentration is C, nothing, nothing, okay. So we'll say C minus C alpha, C alpha, C alpha, okay. What is the concentration of H plus? Concentration of H plus is C alpha. Let's put the values. What is the value of C given to me? You can see 0.1. So I'll write 1 by 10 multiplied by, what is the value of alpha? Which is 1 by 20. 1 by 20. So answer is 1 by 200, right? But this is not the final answer. This is just the calculation for H plus concentration. Now once you know the concentration of H plus, so you can do pH is equal to minus log of H plus minus log of 1 by 200. Do the calculation and you will be getting, so see how you will do. So minus log of 1 minus log of 200. So this is how you will proceed, and you will be getting the answer as 2.3. Solve it, you will genuinely come to 2.3 as the correct answer. Okay. So that's it. This was all about those 10 important questions which I thought are quite important from this particular chapter. I am not saying any of this question will be coming in the exam or only these questions are the set which can come in the exam. No, nothing like that. This was just a practice session to make sure that if you have covered the chapter, if you did it properly, then at least you should be able to do such kind or such level of questions. Fine? But still, if you want to be very confident in the chapter, then these 10 questions are not enough. Please do practice more questions of the same kind. But if you need my help, you can always contact me. Okay? So, but today this is it for the session. Thank you for the class. I'll meet you next time once again. Thank you very much.